this should be quick. I would recommend using 2 different colors for this. I'm going to do my best to do the same. All right, so we have some different scenarios. Like I said, there's 3 different scenarios, well, 4, I guess. First one we've already talked about, okay, where the vertex of the angle is at the center. So for all my angles, I'm going to use purple here. All right, so our vertex is at the center, and A is here. So we're going to say that X equals A. All right, the angle is equal to the arc when our vertex is at the center. Okay? When the vertex is on the circle, like we talked about, let's see if I can get back to it here. That's perfect. All right, remember, when it's on the circle, this is 80, this is 40, this is 42, this was 84. Okay, so when the vertex was on the circle, there's 2 scenarios. First one is was a chord. So in the scenario portion, we're going to write the type of angle, okay, how it's formed. And the second one is a chord tangent or tangent chord angle as well. All right, for both of these, when the vertex is on the circle, I'm going to do the same thing no matter what scenario it is. All right, so I'm going to do that in a second. Okay, so I said what for the angle? Purple. So if my vertex is on the circle here, like the chord angle here, and here's the arc that it forms, that's A, this is X. Or a second example, chord tangent. So here's my chord, there's the tangent. All right, this is the angle X, and the arc that it forms or intercepts is A. For both of these, okay, for both of these, whether it's scenario 1 or 2, okay, I cannot stress this enough because this kind of trips people up. X is always going to equal the arc over 2 for both. So whenever the vertex is on the circle, I do arc divided by 2, no matter which one of these 2 pictures it looks like. Okay? Well, easy there. All right? When it's inside the circle, floating inside, so here's my angle. And it can be at the center or whatever, it doesn't matter. So here's the angle X right there. All right, here's my vertex. Here's arc A. Here's arc B. When it was inside the circle, remember, I added the arcs and divided by 2. So what am I going to do here? X is going to equal A plus B over 2. Or X times 2 equals the sum of these 2. It's also an appropriate way to think about it. Okay. Remember that when looking at these, that the angles that I'm talking about, I make a huge X to outline. Well, I'm going to use yellow to outline and highlight where to look at. All right. It's hard to see. I apologize for that, but I make a huge X, and then okay, I'm eating these 2 angles, hungry arcs. Excuse me, hungry arcs. Vertex outside the circle. Here we go. Vertex outside the circle. So we're looking at these scenarios here. All right. We had a couple different scenarios, although we didn't name them. I'm going to name them here. Okay. Our first scenario is a secant angle. Remember, these angles are named by the types of segments that form them. I can get a secant. What's my next one? Okay, yeah, secant tangent. Secant tangent. And the last one, and this is a special one, this is a tangent. Okay, I referred to the ice cream cone earlier in a previous lesson, and this is going to be an example of an ice cream cone. And this is a special, and I'll show you what that is in a second. So here, So if it's a secant, remember secants see through. They go through, intersect at 2 points. Here's my angle X. This arc, remember we follow it straight out. It's a hungry angle here. All right, so I'm looking at this arc A and this arc here, B. Remember, you always do the farther arc minus the closer arc. All right, another example, another scenario, excuse me. A secant tangent, like that. Here's X. Here's B. Here's A. Our last one, and this is a special type. This is the ice cream cone. So it's a tangent. Tangent, why do we call it an ice cream cone? Because look, it kind of looks like an ice cream cone. All right. Tangent can follow the same as the other two scenarios. All right, but also has a special little scenario as well. But no matter what, and I'm going to explain that in a second, what I can do for all three of these scenarios is A, the farthest arc, minus the closer arc, all divided by 2 to give me X. All right, for tangent, I'm going to write, I'm going to write the word out, actually. Tangent, and I'm going to draw a separate picture again. All right. Also, so here's a tangent. There's a tangent. This only works for tangent angles. Okay, I cannot stress that enough. So if I have my arc here, this is B, this is X. You could say that X plus B will equal 180. All right. That's only tangent, okay? That's not going to work here with the secants. It's not going to work here with secant. If it's double tangent and I have this ice cream cone, the close arc and the angle and that extra angle will be supplementary. So let's, for example, if I know this is 100, then X has to be 80. Those are just examples. I just made that up. If I knew that I knew that this was, let's say, 45, then this would be 135. Okay, it's a special case. It's just a special case. All right, and that's it for part 2. All right, it went a little bit longer than I wanted to, but I just wanted to make sure you had all of these types in one place for you. All right.